I'll get things kicked off here. Welcome to the webinar on the Klamath Basin dam removal. We've got two really amazing speakers this afternoon. I'm going to just introduce Sue Keitel, who is a retired from the US EPA just recently here in Region 9. And Sue has been working on the Klamath Dam project since 2007 here with the EPA. She started in the water quality standards and assessment section and then transferred over to the watersheds department, and is got a long history on this project from this working with the EPA. And then our other speaker today is Keith Parker. And Keith, I'll let you introduce yourself.
Oh, well, thank you. So my name's Keith Parker, and I'm a senior fisheries biologist with the Yurok tribe up in Northern California. And I'm also an adjunct professor at Cal Poly Humboldt and UC San Diego, Scripps Institution of Oceanography. And I'm really glad to be here today.
Well, great. Thanks for being here. And Sue, I'll hand it over to you.
Okay, great. Thank you. So welcome to the talk today on Klamath River Basin, getting to dam removal. When Jovita suggested this topic, I thought it was great. And it's a great example of the Envirothon questions and topics. How do we balance quality of life and quality of the environment? That's Klamath issues in a nutshell. And it's also renewable energy for a sustainable future. So I will tell you a little bit about the background. Have to make my keyboard doesn't work, sorry. I'll tell you a little bit about the background and cover the regulations and the negotiations and agreements from my perspective working for the Environmental Protection Agency. And I will say there are many passionate stakeholders in the basin involved in the Klamath River. There have been lots of actions that I'll tell you about, so apologies if it's kind of overwhelming. There's been a lot of ongoing conflict over the decades on how to manage basin issues. And getting to dam removal has required a level of cooperation for mutual benefit that was not previously seen in the basin. So a little background for you. Klamath Basin is on the border of Oregon and California, and it covers 12,000 square miles. That is the size of Maryland. There are two main developed areas, and I'm hoping you can see my pointer. One is the city of Klamath Falls, and another one is Wairika here in California. And I'm just going to point out Eureka because I'll mention it later. The basin once supported robust fish populations that settlers and tribes have relied on for food, tribes for cultural practices. So the Klamath River itself is this blue line here, going all the way up to Upper Klamath Lake. And salmonids came into the river from the Pacific Ocean, and it was the third most productive salmon run on the west coast of the contiguous US. And the upper basin supported lost river and short-nosed suckers. There's pictures of both of these down below. And also these provided subsistence to people who lived there. There are 6 dams on the river. The first 2 are not coming out. There is Link River Dam right here at the base of Upper Klamath Lake and Keno Dam right here in Oregon. Those are not coming out. And the 4 coming out are J.C. Boyle right here in Oregon, Copco 1 and Copco 2, and Iron Gate Dam in California. And the basin has several significant tributaries or subwatersheds that are big by themselves. Upper Klamath Lake is fed by the Wood River, the Williamson River, the Sprague River, and the Sican. There's a basin here called the Lost River Basin that used to be a terminal basin, but because of hydrologic modifications, it's now part of the Klamath system. And then below the dams, there's the Shasta River, the Scott River, the Salmon River, and Trinity River, both the main stem Trinity River and the South Fork. And the Klamath Basin is referred to as an upside down river because normally rivers start with pristine watersheds, flowing clear, cold, not much impact or disturbance up in the watershed. And then as you flow down, it gets slower, warmer, it's used more, so it's less clean. Klamath is kind of the opposite in that the upper basin up here in Oregon is a bowl. It's an elevated high desert. It's a bowl with developed community in it, ranching, agriculture, timber works, and all of these uses make it what we refer to as warm and brown, which are not great for a lot of fish, especially salmon. And once you get to the hydroelectric area, it's probably not surprising that the river drops 2,000 feet across these 4 dams. And so it gets going fast, it gets aerated, it cools down, it becomes better quality. And then below the dams, you've got another 2,000 feet from Iron Gate Dam down to sea level here at the Pacific. And you've got all of these huge tributaries contributing water coming from all of it, mostly undeveloped areas. So it gets much cleaner and faster moving. So again, I'm going to figure out how to advance. So the basin has been inhabited by tribes for probably more than 10,000 years. And the circles corresponds, you can see where things are. In the upper basin, the Modoc tribe, the Klamath tribe, and the Huskin Paiute tribes now comprise what are called the Klamath tribes. And then in the middle basin is the Shasta Valley Nation, was the Shasta Valley Nation. And then down in the lower basin are the Karuk, the Yurok, the Hupa, and then ones that aren't shown here is the Resagini Rancheria and Quartz Valley Indian Reservation. And Keith is going to be speaking after me about the tribes, but I just want to acknowledge the incredible importance the tribes have provided to this entire journey, being stewards of the watersheds for eons, doing so much excellent science that contributed to our understanding of what's going on, and then promoting dam removal. So I just want to make sure that it's really clear that they are important players, and I'm not speaking about them so that Keith can. Okay, so land uses in the basin. We've talked about timber and ag, fisheries, recreation. Who owns most of the basin? It is hugely federally owned. So you can see on the map on the right that the dark and light green areas are national wilderness areas and national forests. Purple and raspberry up in the upper basin are national parks and monuments. The orange up here are national wildlife refuges. And the dusty pink in this area is the Bureau of Reclamation's Klamath Irrigation Project, which I'll tell you about in a few minutes. The salmon color are tribal reservations. The square is the Hupa Reservation, and the line along the river is the Yurok Reservation. And the white area are private land holdings, developed areas, private ranches or timber and developments. Okay, so let's move on to the history of the basin so that you can understand the stakeholders and their concerns. So in the 1800s, settlers started coming to the basin for their resources. First, they came for beaver pelts and other furs, trappers. Then in the 50s, the gold miners came, and many stayed and got involved in timber work. And in the 1860s to the 1900s, logging became very widespread with lots of timber mills going in. In the 1880s, railroads came to Wairika and Eureka. And then in 1909, they came to Klamath Falls. And also in 1900, most of the upper basin was vast lakes and wetlands. It was lower Klamath Lake and Tule Lake. And let me just orient you. This is upper Klamath Lake up here in the left corner, corresponding to this area. And this blue line is the Klamath River. And then this is lower Klamath Lake and its wetlands, and Tule Lake and its wetlands. And they provided tremendous habitat for fisheries in this area. And they also really cleaned up the water before it went into the Klamath River. It allowed sediments to settle. Plants took up nutrients so that the water wasn't really nutrient rich. And in 1905, the newly formed Bureau of Reclamation was directed to reclaim or drain all of these areas so that they could be made into farmlands for homesteaders. And in 1908, in Lower Klamath Lake, it had started draining it, and this lower area down here was set aside to be a national wildlife refuge because this whole area was heavily used by waterfowl and Pacific flyway species. So this area, this where my pointer is, was set aside for a wildlife refuge. You might be able to see the corresponding shape over here. And in 1912, remember the railroad came in just before. This black line was a levee that was built for the railroad. It just cut the whole area off from flowing into the Klamath River. And in 1917, this drainage line here had gates put across it so that water couldn't flow back and forth, reflooding this area. Similarly, Tule Lake had dams and things built so that it dried up. And it also, in 1928, had this lower corner made into a national wildlife refuge that corresponds to this area over here on the new, more current map. So by 1929, the whole area had been drained. It was being used for growing alfalfa and hay and pasture. And then after World War II ended, the Bureau of Reclamation in 1946 held a lottery for World War II veterans that had farming experience to give out homesteads up to 160 acres each. So veterans were given lands to farm that becomes important later on. And all of this area became what's called the Klamath Project. It looks like this now, very heavily plumbed, managed by the Bureau of Reclamation. And for years, water would come out of Upper Klamath Lake and it would be taken into what's called the A Canal to irrigate all these colored areas that are irrigation districts providing water to farmers. And so taking this water down river, there was much less of it for the fisheries downstream. So Tule Lake, you can now see the sump area that corresponds to the map, and same with Lower Klamath Lake. And water from these irrigation areas ultimately flows back into the Klamath, but the wetlands are gone. So it flows back in as warm, brown, muddy water. Okay, so let's go back to 1920 and look at the next change in the basin that was important, and that is bringing electricity to the basin, the hydroelectric dams. So in 1922, the first dam was completed. COPCO stands for the California Oregon Power Company, and it was completed in 1922, as I said. And then in a few years later, COPCO 2 was completed just downstream, right in the middle of the basin. And then a number of years later, J.C. Boyle Dam, which is the most upstream of this four, was completed. And the fourth one was completed shortly after that in 1962, the Iron Gate Dam. And it's worth pointing out that Iron Gate Dam is the tallest, but it provides the least electricity, only 18 megawatt maximum capacity, as it was primarily built to buffer downstream impacts so that the hydroelectric practices wouldn't release a pulse that could drown somebody with intermittent flows. So I also want to say the dams were built to produce electricity, which may seem obvious, but they were not built for water supply or flood control or other uses. And let's look at how were the dams regulated when they were first built. The Federal Energy Regulatory Commission licenses energy facilities, including hydroelectric projects, overseeing any physical changes, ownership transfer, decommissioning, which will come up later in this talk. And the hydroelectric dams operated under a long-term 50-year license that was good until 2006. And when that license was issued in the 1960s, environmental regulations didn't exist yet. And they were being envisioned and starting to be developed by the feds in California. And once they did get developed, FERC would have to shift responsibility to strike a balance between the developmental interests and other interests like environmental regulations and complying with statutes. But the permit had been issued, so those weren't captured until when a new permit would have to be issued in 2006. And Pacificor would then have to comply with the environmental regs. So what are these environmental regs that were important? Let's look at those. And they came about in the 70s, mostly. The first and probably the most important one is the Endangered Species Act. And California developed an Endangered Species Act a few years before the feds. But in general, the purpose of it is to protect and recover imperiled species and the ecosystems upon which they depend. So for the federal side, freshwater issues are handled by U.S. Fish and Wildlife Service, so the upstream issues. And the marine and anadromous fish that come and go between the ocean and freshwater are managed by NOAA's National Marine Fisheries Service, NMFS. And in the basin, there are two fish that are listed as endangered. Down in the lower basin are the coho, and they have been blocked by the dams and have had severely declining populations. And in 1994, commercial and recreational fisheries in California in that area were closed because the populations were so down. And in 1996, any taking of coho other than tribal was also prohibited. And a year later, in 1997, both California and the federal government listed coho as threatened, so likely to become endangered in the foreseeable future. And the causes they cited were that there was poor water management, poor water quality, loss of habitat, and overfishing. And after that, NMFS had to develop what's called a biological opinion, a BIOP, and that is what are the requirements that people must comply with to protect the coho. And that included setting river flows to maintain their habitat and to provide enough water for the coho. Looking upriver in the upper basin at suckers, here's a Lost River sucker. It's a similar story, but a little bit earlier. In '86, the sucker fishery was closed. In 1988, U.S. Fish and Wildlife Service listed both suckers as endangered, meaning there is a danger of extinction throughout all or a significant portion of their range, their habitat. And the causes were cited as habitat degradation and alterations to natural hydrology. And in '93, they published a recovery plan, and then a biological opinion was published requiring that the levels in Upper Klamath Lake, the water levels, had to be maintained to protect the sucker and their habitat. And the Bureau of Reclamation, you might remember, manages how water coming out of Upper Klamath Lake is handled. So it fell to the Bureau of Reclamation to make sure that the levels in Upper Klamath Lake meet the requirements and that water discharged enough goes downriver so that it meets the requirements for the coho downstream. And only after those requirements are met can they give water to irrigation and other uses. And just quickly, I'll point out there are a lot of other fish that are important in the basin, but they're not listed as threatened or endangered. Some of them are Chinook salmon, steelhead, lamprey and eulachon, and green sturgeon. So the next environmental reg that is important to Klamath is the Clean Water Act. And it was adopted in 1972 by the feds, 3 years after California adopted their California's Porter Cologne Act, their water quality standards. And the Clean Water Act, the Federal Clean Water Act, addresses many things. It gives states and some tribes primary responsibility for implementing specific elements. And there's two elements I want to highlight for you that are relevant. I'm going to jump to the second bullet first. Section 401 allows states and some tribes to ensure that federally permitted activities comply with state or tribal water quality laws. And they do that by issuing a water quality certification to the agency permitting an action. In this case, FERC would be permitting PacifiCorp. So the states would have to issue a water quality certification. And those certifications can include conditions and requirements. So California and Oregon both developed water quality certifications and said PacifiCorp has to do the following things with the dams. You know, they can specify that sort of thing when the dams would be subject to relicensing. The other item that's really important, the other element of the Clean Water Act, is Section 303D, which says for water bodies that do not meet water quality standards, and there are a lot, the state or each state is supposed to prioritize the waters needing further assessment first. So the highest priority waters would then have water quality improvement plans called total maximum daily loads, TMDLs, developed to say, this is the source of the impairment. This is the reductions that are needed from each pollutant source to meet water quality standards. So for example, there may be a requirement that forestry or ag practices have to reduce the sediment runoff from their practices so that there's less sediment in the river. And helping to elevate the priority for Klamath, in March 1997, Earth Justice and 14 groups, fishery groups and environmental groups, sued EPA to complete TMDLs for a number of rivers on the Northern California coast where activities weren't protecting water quality. And the Klamath River and its tributaries were included. And the way the lawsuit was settled was there was an agreement to do the TMDLs on a schedule, and EPA worked with the North Coast Regional Board to complete those TMDLs. And for the Klamath Basin ones, first the tributaries were done, the TMDLs for the tributaries, and then we worked with Oregon DEQ, Department of Environmental Quality, to develop a TMDL for the Klamath River, because the river doesn't recognize state lines, but each state had to have their own TMDL document. And you may have noticed that in 2006, when the hydroelectric project permit was going to expire, we hadn't finished yet. So there was concern that a FERC decision on relicensing would not incorporate TMDL requirements into the permit because we hadn't completed the TMDLs for incorporation yet. Okay, so shifting to the third environmental regulation is the National Environmental Policy Act, NEPA. And it was adopted by both the feds and California's version in 1970. And it requires the federal version that for any federal action that could significantly affect the environment, the lead federal agency must prepare detailed assessments of potential impacts from the proposed project and consider alternatives to mitigate those impacts. And these assessments have to be made available for public comment. So an environmental impact statement or an environmental impact report for the state. And the comments provided to that document must be addressed before deciding on a final way to handle the project. So to relicense the dams, a NEPA EIS and a CEQA EIR would be required, and those assessments would have to address the Endangered Species Act, the Clean Water Act requirements, and other environmental interests and statutes, as well as environmental justice considerations. And this was really important because it gave the tribes, the environmental organizations, the commercial fishing organizations leverage for elevating the environmental impacts caused by the dams and making sure that they were considered in any re-permitting. So I'm going to move on to the 2000 now, and there was a number of crises in the basin that were the manifestation of years of impact. So in 2001, In April, the Bureau of Reclamation was doing its job delivering water according to the BIOPS, and there was a severe drought. So they kept water in Upper Klamath Lake for suckers, sent water downstream for coho, and the water to the irrigators was very limited or basically curtailed. And in May, over 20,000 people gathered in Klamath Falls to protest the reductions in water to the Klamath Irrigation Project. And protesters formed what was called a bucket brigade, where a human chain, side by side, passed buckets of water a mile between the Klamath River and the beginning of the irrigation project canals to protest symbolically. But then they kept protesting, and in July, they actually forced open the head gates, taking water from the Klamath River for the irrigation. And ultimately, this got elevated all the way to the White House. And at the time, the vice president was Dick Cheney, and he stepped in and directed the Bureau of Reclamation to deliver water to the growers. So in November, it went a step further, and the National Academy of Science was directed to review the science behind the biological opinions that delegated so much water to suckers and coho. So moving a few months later, into February of 2002, the 10-year plan, the way they managed water, was revised, and a reduced amount of water was given to salmon and more water was given to the irrigators. And that spring, juvenile salmon in the river that had been spawned the previous fall died from low flow conditions. And in April and May, again, Earth Justice and the Enviros and commercial fishing organizations, you can see that's a stakeholder group that's very important. They filed a lawsuit saying that the ESA was being neglected and wanted to stop irrigation diversions. But their request was denied by the court. And we went through the summer, and in September, there was a strong return of Chinook salmon. But the river was warm, there was low flows, there was that restricted passage of the salmon. They were crowded into pools, and disease spread rampantly, and 65,000 returning salmon died in the river. And this was catastrophic. And it was doubly catastrophic because they never spawned. So their offspring would not be returning to the river 3 years later. Moving to 2005, that year in 2005, the tribes alerted the agencies and the public that severe harmful algal blooms were occurring in Copco and Iron Gate reservoirs. And these harmful algal blooms, also called cyanobacteria, were releasing high levels of toxins called cyanotoxins. And health warnings were published recommending that people avoid contact with the water, not use the water, not eat the fish in the impacted area. This clearly impacted not only waterfront property owners and recreators on the river, but it hugely impacted the tribes. HABs continued to get worse year after year, to the point where recently they have been blooming in Upper Klamath Lake, all the way down the river and all the way down to the estuary. And the river is posted every summer. So in 2006, the decision to provide more water for the irrigators was changed again by a federal court decision that prioritized downstream minimum flows for salmon again. So you can see there's a battle of the science for protecting the fish. In April, there was two really big decisions. One was to again close the Northern California coast to commercial fishing. And the other was NOAA Marine Fisheries and US Fish and Wildlife Service together issued a statement saying that dam removal was the best action to address the impacts to anadromous fish. And short of that, fish ladders would have to be put in at every dam to give the fish access to their habitat. And this affected discussions that may have been going on because a popular option called trap and haul was off the books. Trap and haul is literally where You catch the fish below the dam, you put them in a truck, you drive the truck around to the other side of the dam, and you let the fish go. And that had been considered and was no longer on the books. So by September of 2006, FERC issued their draft EIS, which found that relicensing the dam was the best option, but it had to include the requirement for fish ladders. So you can see we're in a no-win situation. Fisheries are in severe decline. Anadromous fish can't get upstream. Fish ladders are now required, and they're going to be expensive. There were battles about the science of how much water suckers and salmon need. Water is not being shared for mutual benefit between fishermen and farmers. And water quality was degrading tremendously, impacting the survival of fish in the river. And by this point, the government, the US federal government, had spent $500 million in the basin addressing protecting impacted irrigators and impacted commercial fishermen and impacted wildlife refuges and others. So there was a lot of push to figure out how to manage the many issues in the basin. And that brought us to negotiations. So why would Pacificor negotiate? They now realized they'd have to comply with the environmental regs and the Clean Water Act requirements. And they also realized in the cost analysis that with diminished flows to provide safe habitat downstream and these other costs, $450 million in upgrades, that fish passage was going to be really expensive, and that relicensing the hydroelectric project just didn't pencil out strongly. So it was not economically favorable for this business decision. And dam removal could be a better business decision if they could control costs and liability. So that allowed the beginning of confidential negotiations between critical partners that are shown here: feds, state, tribes, fishermen organization, irrigated communities. And I'll just point out that for the feds, it was the Department of the Interior, because that is where the Bureau of Reclamation and U.S. Fish and Wildlife Service are. And it was the Department of Commerce, because that is where NOAA, National Marine Fisheries, is. Okay, so out of this, they were able to develop agreements. And the agreement in principle was the first one. It came out in 2008, and it captured the vision and the framework of what would be a final decision in a separate document. And the framework was to plan for and remove the dams if costs could be kept under 450 million. The costs would be split, Pacificor and the states. And instead of doing removal through the FERC processes, they wanted to go straight to Congress and get congressional approval so that Department of Interior could lead the studies. And if the studies pencil out that it's smart to take the dams down, to pick a dam removal entity, and the dam removal entity would then be responsible for getting all the permits. I also just want to point out that this agreement included 22 interim measures that were funded by Pacificor, and these were great. They included an Endangered Species Act interim conservation plan. It also included funding for water quality monitoring the whole length of the river, including public health monitoring for harmful algal blooms. So that was really nice. And in February of 2010, not maybe a year and a half later, they came out with what were the final agreements. The Klamath Hydro Settlement Agreement, which was an agreement to take down the 4 dams, was very limited in scope. And then the Klamath Basin Restoration Agreement. So separately, a very large group of people signing off to say this for a plan that included water sharing and basin-wide fisheries restoration efforts. And KBRA and KHSA would be advanced, again, still keeping the congressional approval. And the KBRA parties, the signatories, agreed to set aside their conflicts with each other for 4 years to allow progress to be made on these agreements. So this was great. We had agreements, let's get to work. So for 2 years, the Department of Interior led studies by Fed, state, local, tribal teams, technical teams looking at 9 different big topics to look at whether or not 4 questions: would dam removal and KBRA advance fisheries in the basin over a 50-year time frame? What would dam removal entail? And what measures would be needed, and how much would that really cost? What were the major risks and uncertainties associated with dam removal? And ultimately, is dam removal really in the public interest? And so these studies went on, and by 2013, 2 years later, there was an overview report that synthesized all the findings of those many technical studies. And then there was a final EIS that came out and identified as the preferred alternative dam removal and KBRA, water sharing, watershed restoration implementation. So the only thing that was left was to get Congress to approve it so that the Secretary of the Interior, the Secretary of the Department of the Interior, could make an official determination to take the dams down. But Congress did not want to get into the business of dam removal. So they didn't act. They just let the 2014 day go by. However, PacifiCorp still had the 4 dams on an expired federal permit and needed to do something. And the other stakeholders still wanted those dams out. So the KHSA parties agreed to develop a third negotiated agreement to keep the dam removal moving forward. So this was called the amended KHSA, signed in 2016. Same parties, but instead of congressional approval, it was going to go through the FERC process. Still establishing a dam removal entity, still the same cost cap. The only difference was California had figured out how to pay the state share. And things could move forward quickly, building on the extensive studies that had already been done and the EIR, EISs that had been done. So they got going. And let's look at what the benefits of dam removal are under the KHSA, the amended KHSA. This is the same slide that I had earlier that was the no-win slide. And while dam removal doesn't solve all the problems in the basin, it helps improve water quality. In the project reach, the reservoirs would be gone, no more harmful algal blooms. And in the lower basin, water would flow more naturally. It would improve anadromous fish access to habitat. It would improve flow conditions that would manage better temperature. It would keep the habitat clean. It provided many benefits. Again, it doesn't solve all the problems, but it would help a lot. And what were the risks? The risks we knew were identified in all the studies and included high suspended sediment loads when the reservoirs were drained, and that would last for several months. It would include the reservoir footprints, bottoms that would need very focused restoration attention and management. There would be cultural and historic resources that needed to be identified, acknowledged, protected. Non-native fish would not survive. And then impacts like groundwater wells near the reservoirs, groundwater would drop, so the wells would need to be deepened. And downstream of the dam, the 100-year floodplain would change. And so some structures may need to be protected. And a lot of these could be managed by picking the timing of drawdown and dam removal very carefully. And the decision was that reservoir drawdown in January and February would provide the least overlap, the least high suspended sediment impact to aquatic species. And then taking the facilities out in a May through August timeframe would have the least impact on the fall run fisheries. So dam removal preparation started. And in 2016, the dam removal entity was selected. It's called the Klamath River Renewal Corporation. It's a not-for-profit organization that was developed only for the purpose of dam removal and restoration. And they partnered with a big construction firm for removal and with a landscape scale restoration firm to lead the restoration work. And together, those firms developed detailed plans, submitted applications for permits, got all the paperwork into FERC. And in 2022, FERC approved the decommissioning of the dams and approved the license transfer from Pacific Corp to KRRC and also to the two states as co-permittees, since KRRC was not a known entity with a long track record. And in 2003, just last year, they got busy with preparations for drawdown, building roads, repairing, strengthening bridges, and they removed COPCO 2. That's what this picture is here. And I hope you saw the time-lapse video of that. It's really neat to see. And then earlier this year, in 2004, I'm sorry, this is a little blurry. In January and February, each of the 3 remaining dams were opened partially to allow for initial drawdown, drain the reservoirs. And by February, restoration efforts were already getting underway on those newly exposed sediments. And now, as we're in the spring, right here on April 2nd, they are waiting for spring rains, spring snow to finish so the river can stabilize. And they will then earnestly start doing dam removal. And actually, they have started already doing some removal of Iron Gate. And again, with the goal of being out of the river by September when the fish come back. So it's really exciting. Every time I turn around, there's more neat news. Some pictures that I thought might be helpful are before and after. This is a picture of Iron Gate Dam, beautiful, full of water. And this is the same after they were drawing down just this little teeny port way down here is how they drained it. You could see the water level way low. They've already put in roads to get down to start handling restoration work. And additionally, in the footprint of Iron Gate Reservoir, the river is trying to figure out what its path is going to be. It's got to carve through a lot of accumulated sediments. And similarly, the tributaries, this Jenny Creek that used to just dump into the river, to the reservoir right here, it now has to also carve a path. Actually, just in the last week, there's a new YouTube up about how they're trying to help this carve so it doesn't turn into a really steep canyon that keeps dumping sediment. So looking forward, again, dam removal is only part of the solution for the whole basin, but it is a huge part. And it will take time and a lot of money and a lot of cooperation to keep improving the basin. And that's going to be done through stewardship and restoration efforts. There's really big ones like the Integrated Fish Restoration and Monitoring Plan, IFRMP, and there's stewardship groups. There's a great example in your additional learning resources that I put in about the Scott River watershed, their February meeting and their tour. It just gives you an idea of what watershed teams can do. In the Klamath project up in the irrigation area, they're looking at a plan for maybe putting back some of the wetlands right as the irrigated area drains into the Klamath River to help clean up the river, settle out those sediments, and absorb some of the nutrients. There's a group called the Klamath Basin Monitoring Program, KBUMP, and they are a group that coordinates, collaborates, and implements water quality monitoring and research in the basin. And they try to share their resources so that everybody can benefit from knowledge. And tribal stewardship is huge, but I will leave that for Keith to describe. And that is the end of my presentation. Thank you. And I will stop sharing. If I can figure out how. Stop sharing right there. Okay. Did I stop sharing? Okay. Keith, it's all yours. You're on mute.
Great. So we're saving questions till the end. Awesome. Okay, I'm going to go ahead and share my screen. Here we go. All right, is that sharing well?
It is now, it's in
Yes.
presentation mode.
Yep.
Great.
Yeah.
Awesome. Okay, so good afternoon, everybody. It's almost evening, and I did a brief introduction of myself before. So just as a reminder, I'm a senior fisheries biologist in the Yurok tribe. We're the largest tribe in California by population and by area. And then the Hupa tribe, which is also in the Klamath Basin, is the second largest tribe, followed by the Karuk tribe, which is the third largest tribe. Besides being an enrolled member of the Yurok tribe, I am also Hupa, Karuk, and Tolowa. So the three largest tribes in California reside in the Klamath River Basin that we're talking about today. So I'm going to go over a series of slides and share a lot of information. I actually have a lot to go through. I don't know if I'm going to have time to get through all my slides at this point. But let's just jump into this. Let's talk a little bit about what I do as a senior fisheries biologist for the Yurok tribe. So I'm the harvest management director. So I'm in charge of the Klamath River that runs through the Yurok Reservation for the 44 miles from the confluence of the Trinity River to the Pacific Ocean. I oversee the net fishery as well. The Yurok tribe is one of the only two tribes in California that has a gill net fishery that's completely defined in our sovereignty and by the state of California. And we also have a federal fishing treaty with the federal government. Over on the left there, that's me in a jet boat. I spend about 30–40% of my time out on the river or doing field work, and I spend about 60 or 70% of my time in the labs or in my office. So I know a lot of you are students here, so if you're looking for a great career, look at wildlife, fisheries biology, hydrology, geomorphology, where you get to have a nice mix of being out in the field and being in helicopters and boats and all kinds of cool stuff, and then also being in the lab. Uh, more of the work that I do on the right-hand side there is I catch a lot of fish in gill nets, like right there at the mouth of Blue Creek, for instance, when they stack up in the fall. And I bring my microscope, I lay out on my belly on the beach, and I cut the gills out, and I'm looking for disease pathogens in their gills. I'm looking for a disease called ick. I'm counting spores. And then I also look for sea shasta. Ceratonova shasta is a common disease that we get in the late summer and fall in the Klamath River Basin. And then on hatchery fish, we recover coated wire tags, which is the upper left-hand corner there. At the hatchery, before the fish is released, the salmon, they're injected in their snout with a small little tag that we call a coated wire tag. I'll talk more about that in the next slide. And then I do a lot of work with the Army Corps of Engineers in the lower left-hand corner there. That's a LiDAR survey. So prior to dam removal, we did a 3D image of the entire Klamath River Basin from all the way from the confluence into the Pacific Ocean, all the way up to Upper Klamath, Klamath Falls. And so by having that sideways looking sonar, that 3D image, we're able to look at different models of running different flow regimes when we did blow the dams and seeing what effect those flow regimes had on the lower river, basically the safety of people and of property. So that's the coated wire tags I talked about earlier. Those coated wire tags that are in the snout of those fish, they're only a millimeter long and they're the thickness of a human hair. But on each one, there's a unique code, as you can see there on the right-hand side. And I look through that through a microscope, basically, and I decipher that code. And it tells me like what hatchery the fish was released from, when it was released, and how many were released with it. If it was released as a yearling or a fingerling. And then that's some of my crew in the lower left-hand corner. We're doing scale analysis and coated wire tag analysis. So then So that's how we, learn all our information about the returning hatchery fish. They have these coded wire tags in them, right, which tells us a lot of info. But for the natural origin fish, or you can call them wild fish, we use scales. So I have up to 15 technicians that work for me throughout the year, and we're out there. We have about 7 boats in the fleet that I'm responsible for. And over that 44 miles of river, we contact fishermen, and we are taking scale samples from their salmon, including Chinook, coho, and their steelhead. Obviously, we're not doing it to Pacific lamprey or to sturgeon because those anadromous fish don't have scales, if you weren't aware of that. And so you get really good at this over time. I age about 5,000 scales a year. It takes me about 2 months. And I get the scales from the entire basin. They're not just from the Yurok. So everyone sends me about 13 other entities, from even the Salmon River Restoration Council, the Shasta River, the Scott River, Indian Creek, Rock Creek, Elk Creek, the whole Trinity side. They send me these scales, and then like rings of a tree, I'm able to age them pretty accurately, with over a 90% accuracy rate is what we shoot for. And that's really important. Why is it important to have this information? Because each year, the Yurok tribe and others that are part of what's called the Klamath River Technical Team, we all meet in Arcata the last week of January every year, and we completely recreate the entire run of the previous year using scale analysis, using coded wire tag analysis, using genetic analysis, and we come up with numbers of fish that ran for that year, and how many returned to each subbasin in each creek. And then we also break it down by age proportion. So we know how many age 2-year-olds, 3-year-olds, 4-year-olds, 5-year-olds there are. And we do that by doing that scale analysis. Then on top of that, I do a lot of genetic work. So my background is actually in fisheries genetics. I have an undergraduate degree from Cal Poly Humboldt in fisheries biology. And then I have a graduate degree, environmental science and management, but I specialized in fisheries and specifically genetics. So on the left-hand side there, that's part of a 5-year project that I started back in 2018. I have 28,000 tissue samples of returning Klamath River, Chinook, spring and fall, to the Trinity River hatchery. And we do a 100% broodstock clipping. So we're clipping every single fish that returns. It's a huge project. And so what my goal is I work with UC Santa Cruz and a couple of PhD students down there. I travel down about every quarter from up here, from Northern California. And we're looking at the level of hybridization between spring and fall Chinook, and the level of hybridization between wild fish, natural origin fish, and hatchery fish. And that's the goal of this project. And no one has done any work like this in the Klamath Basin. So what's really awesome for dam removal is that going into dam removal, we're going to have a really strong understanding of our genetic baseline of our returning salmon. So that way, after we start sampling fish, post dam removal above the current dam sites, we can start comparing what genetic families are the most fit, which genetic families are repopulating better or faster. And then also what type of, microevolution that's going to occur, because there is going to be some type of, strong mutation changes that are going to occur. There's going to be a whole new type of fish that are going to evolve, that haven't been up there for over 100 years. But a lot of my work is on Pacific lamprey. And again, I just want to caution everyone, we talk a lot about salmon. We get very salmon centric, I call it. And for indigenous people such as myself, all of these fish have equal importance. Okay. So I get it. Salmon are important to the economy, and in a capitalistic society, it's about money, right? Huge commercial value. You go to Costco, you see it in the frozen food section, right? You see your sockeye, your coho. You go to a restaurant, you pay $50 for a gourmet salmon dinner and all of that. But there's these other anadromous fish. Anadromous fish, just as a reminder, is a fish that's born in freshwater. It migrates out to saltwater. It lives out the majority of its life history, and then it returns to freshwater and spawns. Okay. Some of them die after one time, which are called iteroparity. I'm sorry, similarity. And then some, like sturgeon, they spawn multiple times, or steelhead. And so those are iteropairs. So just remember that when you hear a lot about salmon, just remember that to native people, sturgeon and Pacific lamprey, eulachon, they were equally as important because they provided food for our people during the winter months when salmon were unavailable. Okay. And these Pacific lamprey, for instance, have about 2 to 3 times the lipid content of a salmon. Okay. So a salmon has like 1.4 to 2.9 kilocalories per gram of body weight of energy. Well, that lamprey that you see on the screen has 6 kilocalories per gram of body weight. Okay. And we believe that it's by design, not by default, that the creator gave us this food during the winter months when salmon were unavailable, when our people needed to pack on the most body weight, when we needed to get on the most fat. So about the time in late November, when the coho salmon wane off and stop running, these fish enter the Klamath River Basin in December, and they run all the way through until spring to about the time when the majority of spring Chinook are returning, and then these wane off. So it's been a great mechanism for our people. The same with sturgeon. Sturgeon are running right now, and our spring Chinook have not started entering the river yet. Um, so I did a lot of work in my graduate work at Cal Poly Humboldt Genetics Lab, and I did a lot of work at University of Idaho. I worked closely with CRIPFIC, which is the Columbia River Intertribal Fisheries Commission, and doing all of my genetic work on Pacific lamprey. And lo and behold, who would have thought that in 2018 that I would discover 2 new subspecies or ecotypes of Pacific lamprey that we didn't know existed. And since my graduate committee felt that, hey, this is a Yurok tribal member, he's a Yurok scientist, he collected, 250 samples over a 1-year period, that we should allow him to use Yurok words to name these 2 new subspecies of Pacific lamprey. So I use single Yurok words. And I should back up here, by the way, in this lower right-hand corner, I caught all 250 of those Pacific lamprey using a traditional eel hook that you see sticking up in the sand. So this was an awesome blend, like it says at the top, about indigenous science and Western science. So I used a traditional eel hook that our men have been catching lamprey here since before the last ice age. I say that again, since before the last ice age, tens of thousands of years. And then I took all of those samples and did high throughput genetic analysis on them. So again, don't get caught up in the word traditional when we're talking about traditional ecological knowledge. It's highly adaptive as well, okay? And then ultimately, lo and behold, because of my work that I did there, it was one more nail in the coffin for dam removal, okay? And so I traveled to Washington, D.C., the Robert and Patricia Switzer Foundation, of which I'm a fellow. I was selected in like 2016. They flew me there, and I met with now Vice President Kamala Harris and Congressman Jared Huffman. She was a senator then, Kamala Harris was. And I had meetings with them about these rare fish species that I had discovered, and how, while one more reason why it's so important to get the Klamath River dams out so that we can allow these fish to propagate. A lot of people don't know, but the highest diversity of Pacific lamprey in the entire world exists in the Klamath River Basin. We actually have I shouldn't say Pacific lamprey overall, because there's 7 different species of lamprey that live in the Klamath River Basin. Some are endemic only to the Klamath River. You won't find them anywhere else in the world, like the Klamath similis and the Miller Lake lamprey. Okay, those are not migratory ones, though. Those aren't the ones that go out to the ocean and come back. They're not anadromous. So there's brook lamprey. There's a lot of different lamprey that don't migrate. Then ultimately, it was in the New York Times this last year, feature story about salmon and dam removal. If any of you get a chance, you can Google my name in the New York Times if you want to read the article. It was in the Sunday magazine of the New York Times, where like 6 million views. So that was awesome exposure, again, about dam removal and how dam removal is so important to not only indigenous people, but more importantly, to the fish, to the river, right? That's the keynote thing at the end of the day, is that while all the stuff is important to us as human beings, we can't be so selfish about it, though. We have to remember that this is a much bigger story. Okay. And here's a little short video I'm going to play you, because actually this says a lot more than I could say, and a really good job. It's only a minute and a half. Most indigenous people of this basin feel that, the Klamath River really is like the lifeblood of our culture. And since time immemorial, we've lived off this river, and this river has provided for us. And not just in the form of fish, but in the form of a lot of different things. And many of our religious ceremonies revolve around species that the river supports. There's like 46 other species, I believe, something like that, that depend on salmon. So there's the pod. You can see them. There's mostly harbor seals there.
This is where I get to work, by the way.
There's another group there. But normally they're up here further. This week they've been up closer, but right now it looks like they're just napping after having a big feast, probably. It's a pretty amazing process the way it works. You know, these salmon bring back all these marine derived nutrients, right? And all of those nutrients, you know, and they're contained in those fish from the ocean. Well, those carcasses are drug out into the forest by many different species that eat on them, right? And those carcasses decay and they're absorbed into the ecosystem. And so we wouldn't have redwood trees, we wouldn't have conifer forests if it wasn't for returning fish like salmon. How else can you get marine derived nutrients in that kind of mass hundreds of miles upriver?
Okay, so like I said, a short little video, and I just think it's really cool. If you ever want to go on and watch the full series, you can pull it up. It's on Tending Nature on PBS, and then there's also another one from well, you just Google Tending Nature and Yurok Tribe, and there's a whole bunch of stuff on our condor and a lot of other things that we do in water restoration. Let's see if this is going to let me advance. Okay, it's fighting me. I apologize. This happens sometimes. I'm not sure why. We'll go to the next slide. Okay. Bear with me. I'm not sure why this is doing this, but it won't go to the next slide. Sorry about that, everybody. Let's try this again. I just exited and came back in. Can you guys see it okay now?
Yep.
Yes,
Yep. It's all
perfectly.
good.
Okay. So let's talk about the recent history of how we got here. Dam removal. It started a long time ago, obviously, you know, so when Sue before me talked about, you know, first contact, it's only been 200 years since we actually had first contact. We were one of the last tribes to be contacted in the Klamath Basin because it's such a rugged basin and we're so far out west. So a lot's happened in the last 200 years. But the culmination of a lot of that came down in my lifetime, actually. So I remember the salmon wars. We actually had salmon wars to get our fishing rights back. That was back in the 1970s, and I was a child, and I was on the river fishing with my grandparents, and I got taken off the river. I wasn't allowed to go out and fish because it got so violent. We had federal troops literally on the river. I could still see them in my mind going past me, boatloads of them with M16 rifles and 3-foot riot batons, and for nothing more than doing what we had been doing since time immemorial, fishing and exercising our fishing rights. It was a really tough time for our people. And that's me at 12 years of age in the front of my grandfather's boat doing, like I said, what I did, grow up fishing and hunting on the Klamath River. Pretty awesome. But last year was the 50-year anniversary of the court case that changed all that. So AWOC Raymond Matz, when we say AWOC in front of someone's name, it gives them respect. It means they've deceased and they're no longer with us and they're in the afterworld. And Raymond Matz, he fought the federal government, as a lot of us did, and he ended up getting arrested and he went to court. And there was a famous case, much like the Bolt decision up in Washington State. Our case was the Matz versus Arnett case. And we celebrated the 50-year anniversary last June, and we actually named the boat ramp down at the mouth of the Klamath River after Raymond Matz. And so the courts held that the Yurok tribe, the Hupa tribe, have fishing rights that were grandfathered, of course, and that we were, it was became the law that we were to get 50% of the harvestable surplus of salmon in the Klamath River Basin. So from that point on, from back in 1973, we were allocated 50% of the harvestable surplus. And so the other 50% goes to like ocean commercial fishing, ocean sport fishing, river sport fishing. So to this day, that's how we get our allocation and our quota, which PFMC recognizes and is enforced. And as Sue talked about, it's been a tough history. I'm just touching on a few of the high points. She got a very fine scale, and so I won't spend a lot of time going over that, which is good that I didn't spend a lot of time in it because I didn't realize how detailed she would get, which was awesome. But the takeaway for me out of all of these things that have happened was the 2002 fish kill. It was absolutely just appalling. I was there for that, and we estimate 68,000 fall run Chinook adult salmon, the largest adult fish kill in the history of the United States, occurred. And it was absolutely horrendous and devastating to our community. As Sue mentioned, the Bureau of Reclamation cut our flows because they diverted water to agriculture and for ESA purposes, to the point that the water was ridiculously low. It became superheated, 78, 80 degrees. The low dissolved oxygen, it caused rampant disease. These fish all huddled in the deepest holes they could find. And so they were in unnaturally close proximity. So once the disease broke out, it just spread like wildfire. And just to give you an idea how it was, that's me 2 jet boats ago when I wore a younger person's clothes, and I'm up at Apaw Creek, right around the corner. Blue Creek is just down below me where my pointer is. And this jet boat, as most jet boats that are jet drive, will run in 6 inches of water. Well, nowhere across the river here at Apaw Creek, and this is the Klamath River in 02, right when the fish kill started, was it deeper than 6 inches. So I literally ran aground in the middle of the river, and we had to use shovels, and it took us hours to dig like a pit all the way down to get into some deeper water so I could float the boat out of here. That's how far they cut our flows. There were fish going by me, the few salmon that could get through, and over half their bodies were sticking out of the water. Only their gills were underwater. And of course, none of those made it. The ones I saw go by probably died within, a day, a few days at the most. They were exposed to the sunlight, and dissolved oxygen was just so low. It was devastating. Again, all of these things were contributing factors of like how angry all of us were, about dam removal. Remember earlier in that slide what it said that, I did a lot of what I do out of anger, and I use that as fuel that motivates me. I turn my anger into something else. I turn it into fuel that says this isn't okay. And so really, for me, dam removal became in my sights after this fish kill. This is when I really got serious about it. And I went to a lot of protests. I went to Sacramento and spoke. I wrote a lot of letters. And I was there in the 08 signing in Oregon when the initial agreement was signed with, our governor, Arnold Schwarzenegger, and others. That's me on the left with a bullhorn. And one of our sisters who's passed away, AWOC Jeannie McCovey, and she was a strong proponent of dam removal. And I just wanted to honor her because she was very instrumental. It's just like Troy Fletcher, AWOC Troy has also passed. And many of our people that were part of this in the early days have passed on tragically. So I'm going to talk about a little bit about us as about a people and about the river and about our food. And all these pictures that you're going to see that I'm going to kind of scroll through while I'm talking, these are all my personal photos. And my point in showing you those is not like, hey, look at me, look at it. I want you to notice. I want you to notice how we still live, how we still eat, that this isn't something from the past. This is still current day, that we're still here. I've had people actually say to me when they'll say, oh, I'm Native American, I'm a member of the Yurok tribe. People have actually said to my face, oh, I thought all of you were dead. I didn't even know, you were still, there were still any Indians left. So I get that, right? And so as a tribal scientist, my work merges the paradigms of my traditional ecological knowledge and my Western science. And so I push back against this false narrative that science isn't related to social justice. Okay. The two can't be separated from our perspective, because species loss not only represents a loss of biodiversity, but this is a loss of our cultural heritage. This might be a good time to do a quick definition of traditional ecological knowledge for those of you that don't know. You can call it indigenous science, you can call it TEK, whatever you want to call it. But an easy definition is that TEK is basically a cumulative body of knowledge and practices that's handed down generationally through our traditional stories and our songs and our beliefs. And when a people does this over and over and over again, over thousands of generations, you develop what's called a place-based identity, or an inseparable connection to place. And so for us, our inseparable connection to place are salmon, the Klamath River, sturgeon, Pacific lamprey, acorn, redwood tree, and the list goes on. Okay. So these are pictures of my kids that you've been seeing, my family. This is what we eat. This is how we live. We still live this way. We don't have the ability to run to Costco or run to Safeway. So all of what you're seeing is this is why this is my calling, right? Because for us, the river is our grocery store. In fact, I'm not laughing because it's funny, but it's just interesting. The closest grocery store to Klamath, California, the headquarters of our tribal reservation, we're a population of 6,500 statewide. Yuroks don't all live there, but we're still a large tribe. The closest grocery store is 25 miles away in Crescent City, through some of the worst roads in California, where the highway is literally sliding into the ocean as we speak. And there have been one-way traffic lights there for like the last 10 years. And so, prior to European contact, it's estimated that indigenous people of our basin ate around 2 million pounds of Chinook and coho salmon annually. You can compare that to a contemporary value of about 100,000 pounds. Okay, so we've lost a lot. And so this loss of our indigenous diet has affected our food security and our food sovereignty. A lot of people have never heard that term. So I get people asking me, what's food sovereignty? And it's really the right of a community to define its own diet and shape its own food system with access to all historical foods, like what you see on the screen here. These are photos again of mine. In the lower right-hand corner, those are sturgeon eggs, right? The left-hand lower corner, that's sturgeon getting ready to be cut up and put in the smokehouse. Up there in the upper left, you've got surfish and salmon collars I just took out of the smokehouse. On the upper right, those are Pacific lamprey cooking on the coals. And then up above, I have lingcod that I caught the day before, and then salmon that I caught that morning. And I'm cooking all that down at the beach at one time. So I'll talk more about this in a minute about, this word traditional and TEK, but I just really want to get that point across. So at the core of our tribal sovereignty is this food sovereignty. And the reason is because these foods that you're seeing on the screen, they feed much more than our physical bodies. For us, for our people, these foods feed our spirits. And frankly, it's because these represent our living link with the land. You know that old saying, you are what you eat? Well, we eat the earth. And so no matter where your people are from on the globe, whether you're from Ireland or Australia or China, England, is that food, language, art, religion, political makeup, all of these societal constructs, they evolved together, right? Synchronously, not independently. And so when you remove any one of these things from that equation, like food, it terribly impacts all of the other things. And remember, we lost nearly all of it. We've almost lost all of our traditional food, our religion, and our language. And so this is what the Klamath River, this is from a document that I helped co-author. It was 30 authors of us, a 135-page document of repopulating the Upper Klamath Basin post-dam removal. And as you can see, many of our fish are over 90% wiped out, okay, for a lot of the reasons that Sue talked about: loss of habitat, water diversions, low dissolved oxygen, disease, DDT use back in the day, over mining, over logging, all of these things. Our spring Chinook salmon, I want to show this because they've really been hit the hardest. So two of our predominant natural origin spring Chinook streams, in the red is the South Fork Trinity River on the Trinity side. And then on the upper Klamath side, where the dams are coming out, is the Salmon River. You can see what's happened though since around 2011. It's like the backside of a roller coaster. In fact, last year in 2023, only 4 adult spring Chinook returned to the South Fork Trinity River. Think about that. 4 salmon. So, and by the way, these are all done by snorkel surveys. 242 salmon only returned to the Salmon River. Since about 2017, not more than 30 fish have returned to the South Fork Trinity, and up until these last couple of years, not more than 100 to the Upper Klamath on the Salmon River. Well, it's really the Middle Klamath, but we call it the Upper Klamath because it was until now. Once Iron Gate comes down, that whole area is the Middle Klamath. But the point is that the reason this is important is because the spring Chinook are going to be the Chinook that repopulate the Upper Klamath once the dams are down. Okay, they are the ones that come in early and they do the long run. They have the thick body size, high lipid content to make that long run and go against those big winter snow melt-offs and the big rains of spring and swim up there. And we know from studies that, from UC Davis, from village sites that were examined near Chiloquin, there in near Upper Klamath Lake and Agency Lake, that 3 of the 4 village sites where whole skeletal remains of Chinook were found. We radiocarbon dated them up to 5,000 years old, and we genotyped them at these certain gene locations called Grub1L and Rock1. 3 of the 4 sites, they were pure, what we call homozygous springers. And one of the village sites had both spring and some fall Chinook, which was surprising that fall Chinook, that genotype was found up there. So we know that predominantly it was spring Chinook that made that long run, as most springers do in most major rivers. So some good things that have happened because of these, what you see here in this graph, is that the state of California in 2021 listed Upper Klamath spring Chinook on the state ESA. It's not a federal ESA listing, so that was disappointing, but at least it's getting some notoriety that they need help. And then, of course, last year we had a complete closure, not only in the ocean for commercial and sport take, but in the river. And the Yurok tribe, our council felt that it was the right thing to do, and we also closed our fishery last year. So our people did not get fish during the fall. We only took a few hundred fish for subsistence and for ceremony use at our dances. And here's one of the huge culprits. You want to talk about pollution from dams? Sue touched on it. Cyanobacteria, microcystin producing cyanobacteria. Okay, so cyanobacteria, it's one of the most deadly natural occurring bacteria on the face of the earth. You go to third world countries, it's a problem. People get sick, elderly people, young people, pets die from it every year. Okay, the lower left-hand corner, that's behind Copco. That's in Copco Lake. That was Copco 1. The middle picture is also a summer picture from Copco. If you took that 1 liter water sample and we went down to the lab at Cal Poly Humboldt and we cultivated that sample, we could make enough toxin to kill 10,000 human beings. Okay, and it isn't just behind the dams. In the left-hand upper corner, that shadow you see is the shadow. I took that picture in 2014. That's from the Martins Ferry Bridge. So that's below the confluence of the Trinity River. So even with this big, massive, beautiful, clear river coming in, we still have this nuclear green contamination all the way down into our estuary. Now remember, not only are our fish swimming through this water that we're consuming, but this water is going into our wells, into our groundwater. Our people bathe in it, they swim in it, right? Our women collect roots from the edge of the riparian section of this river, right? Pregnant women in particular, right? And they let those roots dry, and then they put them in their mouth and they soften them to make a baby basket, because a lot of them, are about to give birth, and they make baby baskets from the willow root and the roots. So they're directly injecting this, pregnant women, into their systems. It's just absolutely atrocious. This would have never been allowed if this had been Marin County or Sacramento or LA. This would have lasted what, a year? And those dams would have been down. But because it disproportionately impacted people of color, Native American people, this is what we've lived for many years. And these are the signs. And every single year, these are the signs that go up and down the basin. So the only thing that you would change is the date and the year. And then we're detected at 5 times, 10 times, 20 times. Every year it's a little different of what the safe human threshold is. So no more will we see these signs. That's what I'm just so pleased and so optimistic about, is that I would highly doubt we will ever see these signs again on the Klamath River down on the lower river with these dams out of the way, because that water, would collect, as Sue mentioned, after it goes through the Link and then the Keno Dam, and that water would collect behind the J.C. Boyle Dam and get superheated and sit there and get all stagnant. And then it would flow down behind Copco 1, get more stagnant, then Copco 2, get more stagnant, and then all the way to Iron Gate. So by the time it got down to us, well, you saw the photos. It's just absolutely astounding, that this was allowed to go on so long. And then this is the other thing we've been dealing with in the Klamath River Basin, besides dams, is legacy watershed damage from logging. On the left-hand corner there, if I didn't tell you, and I told you that somebody dropped a bomb there, you'd believe me. But that's how the logging companies left a lot of our watersheds that ultimately would, fill in spawning beds and kill off salmon. And then on the right-hand side, that was 35 feet of mine tailings on the Trinity River side. They used hydro mining when settlers first came here, when gold was discovered, and they would literally hydro mine an entire mountain down to nothing to get the gold out of it. Well, all of that stuff flowed downstream and got some places as deep as 35 feet. But I should show an after photo. Recently, that all that 35 feet has been cleaned up. The Yurok tribe and our watershed programs, we've actually restored that to a complete floodplain for juvenile fish habitat. Clear cutting and deforestation, unfortunately, still is occurring. These are recent photos. All of these photos are actually within the last decade. So you can imagine what impact this is going to have on the basin and on the ecosystem. And why it's really important when we talk about these conifer forests, and our old growth forests were completely cut down, but now we're cutting down the second and the third growth, right? A lot of people don't realize that our coastal redwood trees that are like right outside my window here, that they sequester up to 250 times the amount of CO2 that a regular conifer tree can sequester. Think about that. One redwood tree is equal to 250 times what an other regular conifer tree. But unfortunately, conversely, when you cut them down, especially at the scale that I just showed you, that over time, that's going to release 250 times the amount of CO2, thereby contributing even further to climate change and the amount of CO2 in our atmosphere. I won't go too heavy on this. I was going to talk a little bit in this, but Sue hit this well, and I don't want to run out of time. And so I'm going to keep cranking about the dam locations and what our basin looks like. One thing I want you to take away, though, I'll repeat it from that video, is that connectivity between the headwater streams and the marine. Okay, so way up here where these dams are, and up above there, the Williamson, the Wood, and the Sprague rivers. Think about it. For millions of years, those salmon entered down here. Pacific lamprey entered down here. Sturgeon entered and swam all the way up here. And they ultimately spawned and died. And all those marine-derived nutrients that they're carrying in their body was absorbed into those ecosystems. In essence, what I'm telling you is trees are made of fish. And we know that from doing core samples on conifer forests where anadromous fish return. We find marine-derived phosphorus, marine-derived nitrogen. That's because that connectivity is been going on for millions of years. And in return, the forest offers shade to those streams so that the water won't get superheated. It provides leaves for insects to live on, and those insects fall into the river and feed fish. The roots from those riparian plants provide bank stability for salmon so that the erosion won't go in and fill in their spawning beds, and there's this ripple effect from these fish, right? There's if you have more plants, you have more deer. If you have more deer, you have more mountain lion. That's why we call salmon a keystone species. But it's not just a keystone biological species. I hope you're picking up from my talk. It's a keystone cultural species. That's a huge difference. It has this duality. But then these dams were built and all these red markers, and I call them anadromy barriers, and they cut off this connectivity. It's kind of like when you're watching your TV tonight, and if I came and just cut the electric cord to it, it wouldn't work anymore, would it? It would stop working because we severed that connection. Well, that's what's happened here. We've severed that connectivity. And so now we don't have that exchange of marine derived nutrients. And then we don't have the river giving that sediment flow and that sediment movement, from upstream, downstream. So these are all things that are going to be restored now with dam removal out of the way. And so all of this brings us to a really good point, is this comes down, online right now, you can go online and read a lot of nasty stuff that's being said about dam removal. It's pretty horrible. And Wairika in particular, a lot of racist things are being said, and it's been really bad the last week. I'm actually getting a lot of hate email. I'm just being honest with you, because they view us as the enemy, that we took down, their dams, as they called them. And this is one of the problems, is because there's this diametrically opposed difference between indigenous science and Western science. So the Western science view is that you can view nature as something to exploit, right? We're all familiar with that. Let's dam it, mine it, frack it, log it, overfish it, basically use it for capitalism, right? Create dollars out of it. Or we can see it as something to protect, right? Let's make a national park. Let's make a wilderness area and tell people that they can't go in. Let's make a marine protected area out in the ocean and tell people they can't use it, they can't fish there. The problem is that with both of those Western views, is that you're saying humans are separate from nature, right? You're either saying we have a dominion over nature and we're gonna just use it to make money and exploit it, or we're gonna protect it. Whereas the traditional view, the TEK view, is completely the opposite. Our view is that we are completely intertwined with nature, that we are a part of nature. And with that comes our stewardship responsibility, because everything out there is our brothers and our sisters. And just like in your family, your parents, your brothers, your sisters, you wouldn't harm them. You treat them as equal. You treat them as if they're family. And so all of these things are our family, and they have been our family. And this is the way we have lived for tens of thousands of years. Only in the last 200 years have we done more damage to this basin than in the previous history of humankind. So think about that. Western influence has only been here 200 years, and look how much damage has occurred. I already talked about this. All this stuff evolves synchronously, not independently. It's about how people do things. Yeah, and don't get too caught up on the word traditional. People say, well, traditional, that means it's old fashioned. Well, it's not. As I talked about earlier, I use high throughput genetic analysis in my job to discover two new, species. When I'm running upriver, 44 miles upriver to do fish sampling, I'm using a high speed jet boat with an inboard motor, right? I'm not using a canoe. I could, but I'm not. My point is that culture evolves, culture adapts. All cultures have, and just as ours has. But what we have is we have this mix of traditional and modern, which I think is what makes us very powerful, and our ability to do a lot of great things, like be the major reason that these dams are coming down. So these things that I'm talking about this synchronization with nature, if you doubt this, look around you. It's all around you. If you just open your eyes, here's some really low-hanging fruit. If you look at the tree of life and a human placenta, if you look at a salmon scale, a tree stump, a human fingerprint, you look at a human lung or a tree branch, you look at leaf vein, human vein, and this wasn't by accident, but I left the river network for last. Yeah. And you look at a river network, you see this commonality, this connectivity between human beings, right? Just like I showed you earlier in that redwood tree photo, and I talked about the CO2. While I'm sitting here talking to you, what I'm exhaling, CO2, the redwood tree outside my window breathes in carbon dioxide, right? And what the redwood tree exhales, oxygen, is what I breathe in. Another example of one of these symbiotic relationships. So they're all around us. And I really encourage you as students to study more about what I talked about that connectivity between fish, the ocean, and these headwater streams that are hundreds of miles inland. So every day, a scientist such as myself, and I hope some of you that are watching this go on to become scientists yourself, in whatever field that that you're inclined to, but someone such as myself, if you took my traditional ecological knowledge and my place-based identity and my Western science training at the university, where all three of those overlap, that's where someone like me lives every single day. So I'm constantly borrowing from these three spheres of influence, and I'm using all of them, simultaneously to make decisions about stewardship, about salmon, about the river. Um, so now let's talk about some good news. Well, we already know. We've spent a lot of time talking about it. The dams are on their way out. I won't spend a ton of time on this. We'll just run through these slides. But here's a before and after. Sue touched on it about Copco 2. Copco 2 dam, which was low-hanging fruit. It was only, 32, 35 feet in height. It already is out. And look how quickly the river restored itself. Look at that before and after photo. If someone had said, hey, there was a dam here, for the last 50 years, or longer than that, I guess since the 50s, you would say, no, there wasn't. It's not even possible. So just think in your mind now, use your imagination, close your eyes, think about those other dams, Copco 1, J.C. Boyle, Iron Gate, and see in your mind what it's going to look like when all that debris is out. It's going to be just like this. There's going to be this pristine river all the way from the Pacific Ocean, all the way up to the Williamson, the Wood, the Sprague River, subterranean all the way up to Crater Lake, right? Underground water. So, yep, we've already know about this. We've blown a couple of the dams. This is the latest photos from last week. These are the dynamiting of the J.C. Boyle Dam, and really cool explosions. Some of you want to see more about this. Go to YouTube, search for Swiftwater Films. You see every film that you want to see that's occurred since dam removal has started in the last couple of months. Shane Anderson in particular has got some great aerial photos, great stuff from his drone. Two people near and dear to my heart. Some of you may know them. Amy Cordalis, she's Amy Bowers, the Bowers family from the mouth of the Klamath River, right near where my family is from the Safford Island. She was our lead attorney for many years. She's been, like me, a true river warrior for dam removal. She recently left our tribe as the lead attorney and went out and started her own nonprofit called Riffles to Ridges. Her and her husband, he's also a native man and an attorney, and they've done some phenomenal things to help move dam removal along. And then our fisheries director, Barry McCovey, there as well, who've been on the ground up there pretty much continuously since dam removal started. And then these pictures are just from 3 days ago that were taken by some of our tribal employees. As some of you know, the seed bank that we have collected, state, federal, and tribal agencies, 17 billion with a B, 17 billion native seeds. And so now we have this monumental task of replanting this entire area in the former areas that these reservoirs resided. And we got to get the plants, we got to get the roots in there. Like I talked about earlier, how important those riparian root systems are to prevent erosion next winter when it starts raining. We don't want all the substrate eroding and going down the Klamath River. I thought this was a cool picture. I just wanted to share it. Just came out the other day. One of our tribal kids, he's in 7th grade, Albie McCovey. He's part of the McCovey family. He drew this photo of what his idea of dam removal is. And you could show like the mouth of the river and then going up and then, the snow-capped mountains and the fish jumping over. I just thought I'd share that with you. But let's talk about that briefly. Some of the pushback that you're going to get and you're going to hear is, and I get it all the time, is, this is a bunch of BS. These dams have been here a long time. The fish aren't going to know what to do. They haven't ran in 100 years. And this is such an atrocity that you're taking these lakes away. They have this, like Sue mentioned, a lot of people have this belief that these were built for flood control. No, they weren't. The 64 flood that destroyed pretty much this whole area down here, the dams were in place for the 64 flood, including Iron Gate. And they are not huge hydropower producers. In fact, their turbines are old, they're outdated. They were getting quotes from GE to actually replace a lot of the turbines. But we know from other dam removals, we know from the Elwha Dam removal in Washington State, Sandy River Dam removal in Oregon, the Condit Dam removal on the Little White Salmon in Idaho, and most recently, the San Clemente Dam removal down in the Carmel River in Southern California, which to date is the largest dam removal in California. There's a lot of commonalities. Actually, we've had 250 dam removals approximately in the last 15 years in the Western United States. A lot of people don't realize, but
there's a lot of commonalities, but the one I'm most interested in is that within months, not years, if you talk to the biologists that work there, which I have, they found larval stage lamprey and juvenile salmon miles above these dam sites within months. The Elwha Dam removal, before they even got all of the debris out, they were already seining salmon juveniles upriver. So these fish, they've been getting nosebleeds on these dams, butting their heads up against it. You can't erase millions of years of what the mother has been doing, the Mother Earth, right? With 50 or 100 years of a dam. These fish carry the recessive genes of their ancestors, just like you and I do, right? Like I'm sitting here talking to you, I'm the offspring of those that survived genocide that our people went through. Well, these salmon have gone through their own genocide, right? Everything we've thrown at them, from low water to water diversions to high water temperature and disease and logging, all the stuff that we've talked about in this presentation. And yet they still persist. That's how powerful they are. That's how strong they are. That's why they are an apex species. That's why they're a keystone species, right? They're powerful not only physically, but spiritually is our belief. That's why they're still here. Their spirit is that powerful. I mean, think about it. 4 spring Chinook returned last year to the Trinity River, right? But yet we still have salmon though in the other streams. So these salmon are still coming. And so thank God, the dam removal is happening and we're getting these out of the way. And the other good news about restoring the Klamath River Basin is that our genetic structure on this basin, which I work with directly, has been completely maintained. I'm not going to get, this is heavy science, but just know that it's a good thing that all these colors are separate. These BC stands for your Blue Creek fish. These are your lower river, what we call sonk fish, stands for Southern Oregon, Northern California coastal fish. I don't want to get too caught up on all the alphabet soup. And then over here, you've got South Fork fish, you got your Trinity River fish, and then over here, you got your Iron Gate fish. If you took this same graph and graphed it on the Sacramento fish, they would all be overlapping because they have got, unfortunately, a homogenization of fish down there because they trucked a bunch of their juvenile fish over the years. We don't have that in the Klamath Basin. This is amazing that we have this level of genetic structure still preserved. So these fish still have their genotype. Remember that. And they still have their phenotype. So people go, well, what's a phenotype? A phenotype is basically, kind of lack of a better term, what you look like. I have dark hair. Someone else may have light hair. I have dark eyes. Someone may also have light eyes or green eyes or blue eyes, right? So for salmon, a phenotype would be like one of them is their run timing. That's an important one. So we know that on the Klamath River, we've got spring Chinook, we have summer salmon that we call heterozygotes. They carry one spring gene and one fall gene. And then we have our fall Chinook, right, which are homozygous fall fish. And you could take any tribal member that fishes, and I could lay out a spring Chinook, a summer Chinook, and a fall Chinook side by side. And even my 12-year-old son can pick them out because they look different. They have different body shapes based on when their run timing is. So these phenotypes are still here. And we also know that part of that phenotype is fat content. And so these are fish that I eat. We eat fish a lot. I probably eat salmon 3 or 4 times a week, smoked, canned, barbecued. The picture in the back, that's a spring Chinook fillet. See how that deep red? Those are these early salmon that are starting to come in the river right now. They have this high fat content. That's why they're the best fish to eat of the year. And we feel that the creator gave us those because we went without salmon during the whole winter. So it gave us the most fatty, juiciest, best tasting fish in the spring because we've gone without. The front picture, that's a fall Chinook. See the difference in the color from that fat content? And even when we can them, so that's some of my canned fish of non-smoked, just the straight meat that I do. So the 2 jars on the left, those are spring Chinook. Look at that fat layer. Look, in the one on the right is a fall Chinook. You don't see that red fat layer. So again, genotype and phenotype of these fish have been maintained. And we know, I'm showing you what's called, some people say anecdotal.
Hey,
We know
Keith,
all this stuff to be true because our scientific studies have backed all of this up. Yeah,
can we please speed up a little bit so we have time for Q&A?
sure.
Awesome, thank
Sure.
you.
I'm almost done.
Okay,
So the next
perfect.
few slides, These are just scientific studies that back up what I'm already talking about fat content and then the run timing of these fish. But we didn't need these studies to tell us this. Our people have been living this. We know this. We were the original scientists on this land. And this is my last slide. And and this is part of that document I talked to you about earlier, the implementation plan for the reintroduction of fish on the Upper Klamath Basin. I was one of the co-authors. It's 135 pages. If you get a chance, you should read through it. It came out. What's the date on that again? It was December 2021. And this is one of a big takeaway of good news of showing going forward, like year 5, year 10, year 15, and 20, that you're going to see like 0.5 is a 50% increase, 1.0 is a 100% increase. So once we get through these initial few years, when you get down here into like year 10, you can really start seeing a jump. Look at year 12, year 13. For all fish, we're looking at like over 100% increase of our current runs. When you get up here into like year 17, year 18, you're looking at like 175% increase of what our current run sizes are. And then when you get past that, people ask, what are these cycles? These are just the natural salmon cycles that you see everywhere. These are based on El Nino and La Nina ocean conditions, where you get these cycles based on food supply in the ocean. And that's all I have to say. So sorry I went a little bit over. I got started a little late, so I wanted to be done by 5:30, but there we go.
Oh, all is good. Thank you so much for your presentations too, and Keith, absolutely amazing. Really opened my eyes about this whole Klamath Dam project removal project, and of course the cultural significance of that region. This was like a huge crash course for me. Um, I guess to start, I have a couple questions to shoot towards Keith's way. Um, how much, how many hatchery fishes currently support the populations and runs in the Klamath River Basin? And with the removal of dams, how quickly do you think wild fish will be able to sustain the populations?
So spring Chinook in particular are largely supported by hatchery programs. The Iron Gate hatchery, before it went offline recently, because there's no water now in the Iron Gate Reservoir, yay, to support it, but Fall Creek hatchery is taken over. But the Trinity River hatchery has a spring Chinook program. There's been a lot of hybridization, though, that's occurred between our natural origin stock and that Trinity River hatchery. The majority of our spring run on the Klamath River Basin is from the Junction City Weir to the Trinity River hatchery. That's where the majority of those fish are. And a lot of those have been strays and have intermingled over the years. But thank God we had that program, because again, those fish are all little repositories. They're all like little bank accounts carrying the genes of that spring gene. And as some of you know, we are beginning to take a lot of those yearlings and we're trucking them up into Oregon. Because remember, the Trinity River and the Upper Klamath, the UKTR fish, are genetically related. They're more genetically related, closely genetically related, than an upper fish is to a lower river fish, like a sonk fish. We actually have multiple ESUs on the Klamath River Basin that we manage for, based on genetics. And so already we've done experiments, Cal Poly Humboldt, UC Davis, we've trucked up thousands of fish. We were tagged them and released them, up in the Upper Klamath Lake area, and looking at how much telemetry hits we got on those fish down below the Link Dam. And I believe it was around like 45% of the fish made it and survived, and went back down. So those are going to end up being a large amount of our brood stock for repopulating those fish. So our wild origin, unfortunately, as you saw in those graphs, are greatly limited. And so, but, again, you got to remember on your nomenclature, just because the fish come from the Trinity River and they are spawning in natural waters, that doesn't necessarily mean that they are, wild origin fish, because of this amount of hybridization that's occurred over many years, between the Trinity River hatchery fish and the fish that were spawning in river up there.
If I may, this is Jovita. I am monitoring a question in the chat before we get on to Carter's raised hand for a question. And I think this is for Sue and as well for you, which is what's the process of working with UROC and other tribal governments on projects like the one discussed?
Thanks, Jovita. I'll start and Keith can cover. So EPA, I can speak for EPA. We have what we refer to as tribal trust responsibilities. When there are actions that are going to be taken, we have a responsibility to reach out to the tribes that may be affected and talk with them, get input, offer an official consultation with a capital C if they would like it. But we go out of our way to work with the tribe. And it was a joy working with the Klamath tribes on the TNDLs and on the secretarial determination studies, getting input, getting feedback, having the tribes provide the scientific knowledge, the place-based knowledge. But it's a responsibility and a partnership. And Keith, I'll let you add to that if you'd like.
Yeah, I mean, as far as dam removal goes, like working on dam removal, it's like a snowball. We picked up a lot of momentum over the years. And I don't want to make it all UROC centric or tribal centric either. There's been a lot of players that have been instrumental in dam removal on, indigenous side and non-indigenous, and a lot of NGOs and conservation groups and just people that live in the region. And believe it or not, even some of the agriculture people, um, Troy Fletcher, our former executive director of the Yurok tribe that unfortunately passed away prematurely in his 50s some years back. He was instrumental in helping to bring together a lot of these people. But I think that we got to remember that it's a huge basin, 16,000 square kilometers, 12,000 square miles, and we have a lot of players. And I also want to point out that not every tribe is in agreement with dam removal. The Hupa tribe in particular, the Hupa Valley tribe, is not one of the signatures, right? They have not signed off on dam removal. They have a lot of problems with dam removal. And so I got to be careful too, and just remember that when I'm speaking and saying things, I'm not speaking for all Yurok people, and I'm also not speaking for all the tribes of the basin. I'm speaking for like our fisheries program within the Yurok tribe. And mostly the Yurok paradigm, but I also, it needs to be understood that there are like the Hupa Valley tribe that was opposed to dam removal. But as far as working in projects with us, if you want to work collaboratively with us, come to work for us. We need people. And there's a lot of students on here, right? And so I teach 2 classes at the university, and I'm always recruiting from my classes. If you go onto our website, look at all the jobs, the scientific jobs that are available right now. I mean, we need people. Go to school, get your degree, become a geomorphologist, become a geologist, become an ecologist, become a hydrologist, get those degrees and come back and work for the Southern Oregon tribes or Modoc or Siskiyou or Karuk or Yurok. And that's how you could make your contribution is you want to work closely with the tribes, come to work for us and with us and be part of the momentum. It's gonna, as you can see on those graphs, I mean, it's gonna be, a couple decades of work of monitoring and rebuilding and repatriating, and there's a lot we don't know, right? So
Awesome. Thanks for the answer.
Carter?
Carter, I see you have your hand up. So if you want to ask your question, you can go ahead.
All right, so I actually had a couple questions. As the first one is really, you mentioned the Hoopa tribe was actually opposed to the dam removal. What is the legal framework like of working with them through that process? Do you guys just do it? Is there any sort of like arbitration process? What does that look like on the behalf of like the federal government?
So I would put a lot of nuance in that. It's not that the Hoopa tribe did not want the dams taken down. It's very complicated. They are on the confluence with the Trinity River and the Klamath River. And it's a whole nother hours of discussion, but the Trinity River can be taken, a huge amount of the Trinity River water can be taken and sent down the Sacramento River down to the Central Valley and to Southern California. And there was part of the agreement, the KHSA, to take the dams down, meant they had to give up their right to object to that Trinity River take. So it's not that they want the dams to stay up, it's they did not like the details of the legal agreement that they were being asked to sign. They were very involved. They adopted water quality standards for microcystin, the cyanotoxin. It was very important to pushing water quality requirements for the river and the dams. It's like anything, the devil's in the details. And at some point, they just decided on what path they were going to take in this process, which meant that, as Keith said, they did not sign the final amended KHSA. And you let people take their path the way they choose to.
So then what happens now? If they didn't sign, but so do they still maintain the water rights even though the dam is gone?
So they did not have water rights over the dam water. The dam is going to be flowing downriver. There's actually, Keith, you can maybe speak to this better than I can, but it is, it is a natural river and people can protect it and use it, but nobody really owns it. I'm not sure. Keith, do you have a way you want to jump in on that, or anybody else that's online?
I just wanted to follow up
Let's
as far as also another reason, to be honest with you, isn't just about what you talked about, Sue, but the unspoken reason too, that it's a strong one when I deal with the biologists there, is has to do with fish. So because Iron Gate Hatchery has gone offline, they have an egg take goal of about 6 million eggs a year. So now Fall Creek Hatchery has been put back online. It's behind the current Iron Gate. It was there before Iron Gate was built. So now it's already online. As we know, a bunch of fish were recent released from there. Sadly, over 800,000 juveniles got gas bubble disease going through the tunnel there at Iron Gate and passed away. But there's still 3.5 million fish that haven't been released yet. But their egg take goals are almost half of what Iron Gate was. So even though there's going to be another hatchery up there, it's greatly reduced. And the amount of yearlings, which are your best fish, not your fingerlings. Iron Gate used to put out about 1.2 million yearlings, and I think Fall Creek's only going to put out like 225,000, so a lot less. And so what's going to happen over the next 10 or 20 years is, now as fish are entering the river, the Yurok tribe is going to be catching probably the same quotas. We're going to be catching a much higher proportion of Trinity River fish of what the Hupa tribe normally takes. And so that's a real problem with them. And I can understand that. That makes sense. So we're going to be taking a much higher proportion of Trinity River fish because, frankly, for the next, we're not sure how many years, there's going to be a lot fewer upper Klamath fish coming in until we get the sediment out of the way, until a lot of things change, right? Till the hatchery, we can get like 3 or 4 generations of hatchery fish returning to Fall Creek. And so that's been a real sticking point as well, if that makes sense. Because the Hupa tribe, which I understand, they have a lot of possessiveness of Trinity River Hatchery because they actually co-manage it. And a lot of their funds and a lot of their employees work at the hatchery. So that's part of it as well.
No, it definitely makes a lot of sense. Thank you. I guess just sort of related question to that. So I've actually read a couple papers about how, I guess, concerns with the hatchery fish. I mean, I know you were talking a lot about the genetic diversity of the fish and the differences genotypically. Have you seen any, like, firsthand, I suppose, any concerns with the lack of genetic diversity coming from the hatchery fish and the amount that you guys are putting out there?
Well, I think just in general, we see it throughout the whole west coast of the United States in salmon hatcheries. There was some really good peer-reviewed studies. One really good one was put out, I think, in 2015 or 16 by OSU, where they looked at a cohort of hatchery versus natural origin fish, I think on the Umpqua, don't quote me directly. But anyway, what they found in their findings, which is typical of what other studies have found, is that the difference between the two classes of fish, there were over 700 genetic mutations that were not random. And the majority of those genetic mutations were at gene locations that had to do with three predominant areas: body size, wound healing, and disease resistance. Well, those are three really important areas no matter what organism you are, especially a fish. So we know that, hatchery fish are not as fit as a natural origin fish for a lot of different reasons. And so it is concerning the amount of hybridization that has occurred in the Klamath Basin between natural origin hatchery fish and also between spring and fall Chinook. There's an unnatural level because of the way that the ladders are set up, that they close the ladder for like a 2-week period every year. And you can study more about that or look into that yourself. But that's why I talked to you before that study that I started in 2018, where I'm collecting 100% of all returning fish, spring and fall, to the Trinity River Hatchery, and we're genotyping them all. And we're also going to do parentage-based tagging, which will help answer your question, which is going to give us more info so that we'll be able to go back and look at the parents, grandparents, great-grandparents, etc., of all these hatchery fish. And we'll be able to see which genetic families are like more fit, which ones are returning, like at higher rates, which ones have, a higher age of maturity, things of that nature.
I guess, sorry, follow up to that is, do you think it's worth, I guess this not scientifically proven yet, but you do say there's a concern. Is it still worth it to put all these fish out here? Do we need to be putting this fish out here? And does that like outweigh the concerns about the loss of genetic diversity and like the potential harmful mutations?
When you say out here, I'm not sure what you mean.
Like, do you think we need so I had the chance to sit on another webinar from another actually indigenous person who said we shouldn't be putting the fish out there. We should just let it go back to normal on its own. Would you agree with that? Or would you say we need the artificial hatching stock?
Okay. Well, again, it depends how you use the word artificial. So the original brood stock for Trinity River Hatchery were natural fish many years ago, but over time there's these microevolutions that occur, like I said, within hatchery fish. But my take on it is, from what I've seen in other river basins, that yes, based on our uniqueness on the Klamath River, because the upper Klamath fish are so closely related genetically to the Trinity River fish, that we do have this awesome opportunity to truck these yearling fish from Trinity River Hatchery and release them on the Williamson, the Wood, and the Sprague rivers, let them imprint, and then they'll start returning to those rivers. Because the option is it could take decades or never that fish could reestablish. Because, I mean, the water quality when you get above the dam sites is pretty meager. I mean, we know that there's thermal refugia in the river that the fish will congregate to, but there's not a lot of them. And it could take many decades, for fish to naturally repopulate that whole area. I think over time it would happen, but it could be a human lifetime. But by, translocating these fish, I don't really see how we're doing much harm, since they're in the same genetic family. They're managed under the same ESU. Now it would be different, if someone had actually suggested, it actually was on the table for a while, that we should take some Road River springfish from Lost Creek and like bring them over, because they're genetically similar, but they're much more dissimilar than they are similar. So that was thrown out the window. So I would be concerned if it was an out of basin fish completely. Um, but I'm not concerned because they're within the same Klamath River Basin under the same ESU.
All right, cool. Thank you very much. I appreciate it.
Sure.
All right. Thank you for everyone that came to our California Envirothon Klamath Dam Removal Project webinar today, especially to our presenters, Sue and Keith, and to all the students that are part of Envirothon. I hope you all enjoyed this presentation as much as I did. It was extremely eye-opening, especially the cultural aspects of it. And this will be recorded for future viewing. And take care and enjoy the rest of your evening, and good luck with the rest of your Envirothon, everybody.
Thank you for having us, and I appreciate
Yes.
you being allowed to present. And did that someone had a question? I saw a hand up, by the way. I don't know.
No, that was me, Jovita,
Oh.
clapping because I thought you were so extraordinary, both you
Oh.
And Sue, I learned so much, and I just really delighted in your passion and your knowledge and everything. And Sue, I just thought you were so comprehensive and complete. And I wish I had you as a professor.
I wish I'd had that explanation when I started working on the Klamath.
Yeah, me too.
Both of you.
Yeah.
Thank you, everyone. And thank you,
Thank you.
Thank
Frank,
you
and
so
all.
much.
Take
Take care.
care.
Yep. Thank you.
Bye, everybody.
Bye-bye.
Yep. Bye.
Thank you, Frank.
Yep. Thank you. Take care. Have a good
Take
one.
care. Bye-bye.
Bye.